All right, let's dive into the fascinating world of diamonds. Today, we're going to uncover a secret that really separates a good diamond from a great one, something that directly impacts its sparkle and, yeah, its price. We're talking about diamond symmetry, and it all starts with a very common puzzle.
Have you ever been in this situation? You're looking at two diamonds. On paper, they look exactly the same. Same carat weight, same color grade, same clarity, but for some reason, one is way more expensive than the other. So what gives? What's the hidden factor that's making all the difference?
Well, the answer is symmetry. It's this invisible architecture inside the stone that controls how light bounces around. Honestly, it's the signature of a true master diamond cutter. Symmetry is what makes a diamond not just shiny, but truly breathtakingly brilliant.
So, what do we actually mean by diamond symmetry? You should think of it as the diamond's master blueprint. We're not just talking about its outside shape, we're talking about a deep internal harmony that makes the whole thing work.
Basically, symmetry is all about the super precise arrangement, shape, and alignment of every single one of the diamond's facets. Think of those facets as a bunch of tiny, perfectly angled mirrors. When they're all lined up just right, the diamond just explodes with light. But when they're not, well, that's when you start to see problems.
Let's start with the big picture issues, what we call proportional flaws. These are problems with the diamond's basic foundation. You know, it's kind of like building a house. If the foundation is crooked, it doesn't really matter how nice the windows are. The whole thing is just going to feel off. And here's a little peek into the language gemologists use. They have these shorthand codes for flaws. For example, OOR just means out of round, so the diamond isn't a perfect circle. T/OC means the table is off-center. That big facet on top is skewed, which throws the whole balance off. And GTV is girdle thickness variation, meaning the edge is thick in some places and thin in others. Now, these might sound like tiny details, but they can set off a massive domino effect.
And this is a perfect illustration of that domino effect. You start with one mistake, right? Like the table being off-center. That one thing then causes a chain reaction. Suddenly, the angles of all the surrounding facets get thrown off, and that can even make the whole top of the diamond look tilted. You see, one flaw is rarely just one flaw. They're all connected.
Okay, so we've looked at the diamond's main structure. Now, let's zoom in even closer. Let's look at the windows themselves, the individual facets. And you're going to see a pattern here. Just like with those big proportional flaws, a lot of the smaller facet flaws can be traced back to one single source. And yep, it's often the table again. See, that big flat facet on top of a round diamond, it's supposed to be a perfect octagon. When it's not, a flaw grader's called T/OT for table out of shape. Other things start to go wrong pretty quickly.
For starters, an imperfect table automatically creates what are called misshapen facets, or MFC, because all the facets around it have to be warped to make everything fit. You can also run into other things like extra facets a cutter might add to polish away a little blemish, or even missing facets that just were never cut.
Then there are non-pointing facets, or PTG. This one is all about precision. I want you to imagine a perfect star where every single line meets at a sharp, exact point. Well, PTG is what happens when those lines don't quite meet up. The junctions where the facets come together might be a little open, or they might not meet at a single, crisp point. And that tiny little imperfection messes with the whole pattern of light.
So this brings us to what is, for me, the most interesting part of this whole thing. We've got all these different flaws we can identify and measure, but how does all of that get translated into a final grade? Well, this is where the hard science of gemology meets the subjective art of the human eye. I mean, that's the real question, right? A diamond could have a handful of these issues going on. So how does a grader weigh all that and make the final call between very good and just good on the report? What's the guiding principle here?
The whole thing boils down to this incredible concept called chubahan. It's a Hindi word that literally means to prick. And in the world of diamond grading, it's all about how much a flaw visually pricks the grader's eye. It's not about how big the flaw is on a diagram, it's about how obvious and distracting it is in real life. And this is the golden rule. It's the most important thing to remember. No matter where a flaw is, the final judgment, the grade it gets, is always based on how it affects the diamond's beauty when you look at it from the top, the face-up view. Why? Because that's how we actually look at a diamond. That's what really matters. This is the perfect example of chuban in action. On the left, you've got a small extra facet, but it's tucked away near the edge. You kind of have to hunt for it. It has low chuban, so the grade might still be very good. Now look at the right. It's the exact same flaw,
Same size, but now it's parked right between two main facets on the top. It just jumps out at you. It pricks the eye. That's high Chaban, and that grade could easily drop to good or even fair. Same flaw, different location, completely different impact.
So let's connect all the dots. How do all these different flaws and this idea of chubahan come together to create those final symmetry grades that you see on a diamond certificate?
This table breaks it down perfectly. An excellent grade means that whatever tiny flaw exists is incredibly hard for even a trained expert to find. For very good, it's still difficult. But by the time you get down to fair, the flaw is pretty much immediately obvious. It's got high chufanan, it pricks the eye. And poor just means the flaw is so distracting it really hurts the diamond's overall beauty.
So, why does all of this matter to you? Well, because that drop from excellent to very good, or from very good to good, isn't just a word on a piece of paper. It represents a real, visible difference in how beautiful that diamond is, and it absolutely has a major impact on its value. Symmetry is a direct driver of both brilliance and price.
So the next time you look at a diamond, I want you to look beyond just its size or its sparkle. Look deeper. Look for the harmony, the precision, the perfect pattern. Because now you know its truest beauty lies in that hidden symmetry. So what will you see? Thanks for joining me.